Hello students, welcome to EPG Pathshala. I am Professor Dr. Sujit Bhattacharya, Professor in the Academy of Scientific Research and Innovation and Senior Principal Scientist in CSIR NISTATS. The module which I will be discussing is Scientometric Studies and their role in Science Policy. This is under the paper Informametrics and Scientometrics. In this module, we will discuss the utility of scientometric studies in decision making, policy making. We will examine how technological forecasting provides an informed view of technology, its development and future trends, and thus acts as an important tool in decision making. We highlight the conceptual understanding of technology forecasting, and in this we further argue through examples and through other illustrations how scientometric methods also apply in technology forecasting, and thus scientometrics becomes one of the important tool in technology forecasting. So primarily our objective of this module is to understand the importance of measurement activity in science for science policy decision making, learn the basic concepts of technology forecasting, how scientometrics emerges as an important tool in technology forecasting, and we highlight through examples the application of scientometrics in science policy. When we are talking of science policy, we are in a sense using it as a generic name. Science policy includes science policy, technology policy and innovation policy. So when our highlighting the application of scientometrics is to address these three policy aspects which are in a sense interlinked to each other. Measurement of scientific activity evolved in the late 1960s as a practical need for a rational policy decision in science funding. How this perspective emerged, and in a sense why it emerged. Scientific research were shown to increase exponentially. The amount of resources involved, the manpower involved, and the publication which were coming out from scientific research. This started putting pressure on the S&T system during this period, and it was also felt that some interventions has to be done so that a proper mechanism, or one can say control, can be done externally so that desirable scientific activity and outcome could be achieved. There was the competitive funding pressure of the different streams because of this exponential increase. Peer review system were found not adequate to address different conflicts. Science started playing a much larger role in economy and society, as you understand that right from the primary role science played in during war efforts, and later in the in space during that period, there emerged a need for a more objective standard for funding the scientific activity and direction of scientific research. Scientific research also was much dependent on government support, and government had to properly rationalize how much funding it can provide or give to scientific research in comparison to the other activities or areas where funding from government was required. Scientometric research has led to the construction of varied types of indicators that can address the following main types of scientific activity: dynamic aspects, growth of scientific knowledge, signaling the new areas of research; structural aspects, mapping the cognitive structure of scientific knowledge; evaluative aspects, assessment of scientific research; and prognostic aspects, capturing future trend. Herein we demonstrate how evidence-based studies provide important inputs for policy action. One of the influential findings from analysis of research papers have been the role of research collaboration in advancement of scientific research. This can be observed in different fields of research. For example, 26 papers were identified from India in the top 1% cited papers globally in nanotechnology in 2009. Of the 26 cited papers, 16 papers, that is 61%, were found to be collaborative papers. Again, examining Indian publications in nanotechnology journals with high impact factor showed collaboration playing a major role. Looking at high reception of papers from China also brought out this fact. In a sense, strong evidence emerges that collaboration has played an important role in pushing the quality of scientific research in nanotechnology for both India and China. This is true for other research fields also. In this slide, again we demonstrate the importance of scientometric studies in understanding the policy, in understanding the technology trend. This example is based on examination of patenting activity of India and China in nanotechnology in the US Patent Office (USPTO). The joint patenting among Hon High Precision Industry Limited and Tsinghua University is striking. Both of them they together filed 118 patents during the period 2001 to 09, which accounted for 72% of patents filed by China in nanotechnology during this period. During this period, their joint patenting also led to the grant of 22 joint patents in nanotechnology, which is 49% of the patents granted to China in nanotechnology during this period. We observed the joint patenting activity is not only strengthening over the years but are also directed to specific application. The patents in the earlier application are in varied methods of growing carbon nanotubes. Later patents address specific application of carbon nanotubes, that is in yarn, textile, microscopic, electronic, nanoscale integrated circuit, nano-based display panels for computers, LCD, TV and mobile screens, lithium battery, composite material for automotive, carbon-based array sensor and electron emission device. This example demonstrates how the joint activity of an industry and university leads to patents filing and also contributes towards making important inroads in areas of strategic importance. This is again a demonstration of the importance of capturing through scientometrics the important trends and which act as an input to policy articulations. Technology forecasting. Technology forecasting is primarily understood as all purposeful and systematic attempt to anticipate and understand the potential direction, rate, characteristics and effects of technological change, especially invention, innovation, adoption and use. Primarily, it refers to a set of methods, techniques to identify future technology developments and their interactions with society and the environment for the purpose of guiding nation actions designed to produce a more desirable future. So, when we are talk of technology forecasting, we are talking of not only predicting the future like technology forecast, but we are also talking of how we can look at the present system and how we can make suitable changes in the present system so that the future comes to a desirable end which we desire. Technology forecasting usually focuses on specific technologies, but sometimes its scope is more encompassing. For example, a firm would like to look at a set of related technologies or products in which it is active and try to roadmap it through technology forecasting. Similarly, an industry would try to look at a sector in which it is operating and would try to forecast the future possible scenarios of this sector. And sometimes it is much wider where the nation itself looks at technology forecasting to see that how actions, policy actions can be taken by road mapping the important sectors of its economy where it is active and where it tries or wants to intervene. Technology future analysis. Technology future analysis includes technology monitoring, technology watch, technology alerts. They come under this activity under gathering and interpreting information. The second set of attributes of technology future analysis are technology intelligence and competitive intelligence. This is converting information into usable intelligence. Technology forecasting, anticipating the direction and pace of changes. Technology road mapping, relating anticipated advances in technologies and products to generate plans. Technology assessment and forms of impact assessment, including strategic environmental assessment, leads to anticipate the unintended, indirect, and delayed efforts of technological changes. Technology foresight, also national and regional foresight, helps in affecting development strategy, often involving participatory mechanisms. Some common methods of technology forecasting are highlighted. Expert opinion, they include Delphi, interactive surveys, focus groups, which includes panels, workshops, interviews, trend analysis, which includes trend extrapolation, wherein growth curve fitting is an important area, trend impact analysis, long wave analysis. The third important method of technology forecasting is monitoring and intelligence methods, which goes also under the umbrella of technology watch. Modeling and simulation includes life cycle analysis, system simulation, economic based modeling, input output analysis, technology assessment, scenarios, which includes scenario simulation, gaming, interactive scenarios. For the purpose of this module, technology future analysis and technology forecasting are used interchangeably. Now we look at the relationship between scientometrics and technology forecasting. Scientometrics bibliometrics is one of the popular methods in technology forecasting. Bibliometrics is the statistical analysis of test documents, typically publications and patents. As patents and scholarly journals often deal with ideas and techniques relatively in the early stage of technology development, this is the stage at which bibliometric methods for technology forecasting are most useful. In later stages, the exploitation of knowledge takes place, which requires large amount of tacit knowledge, know-how, practical knowledge, which cannot be captured in bibliometrics methods. Scientometrics plays an influential role instrument in the application of forecasting methods. For example, in many Delphi study, choice of experts is the most difficult process. Who are the experts you will choose so that your Delphi study is most valuable? In Delphi study, as you know, we are looking at experts who can give a detailed perspective of a particular technology and inputs. From that, we experts we further snowball to other experts who can then supplement and complement the experts' knowledge to understand or give direction of how the interactions we will do, so that we reach in this desired goal. I am talking of, if a particular technology is in question, we would see that what would be the actions we will take so that the particular technology develops and we get the economic and social benefits. So as you see that expert selection is one of the most crucial aspects of Delphi study. The scientometrics methods allows us, by looking at the highly intensive researchers who are highly cited, as well as patents, who the prolific patentees and the citations of these patents, to identify the experts from these statistical analysis which are input to the Delphi studies. Further, another example comes, which is very now used in forecasting studies, are the interactions among the different actors. Different actors, we would say, is the university, industry and government. We identify that how the interactions are happening through joint co-authors or joint patentees, which becomes input to the forecasting process. In this slide, we look at the usefulness of scientometrics in the context of foresight study. Scientometric methods helps to identify emerging scientific specialties and research areas, research fronts where action is taking place, technology clustering based on co-occurrence analysis of patent classification codes, keywords from title or abstracts, patent citation network, which are important inputs for foresight study. Patent citation network can help identify in any area of technology the technology plane, precursor and successor technology, key patents, key companies, inventors, and can help identify interactions between science and technology. Scientometric studies also help us to identify core competency of countries in an area of scientific research or technology, and in the context of foresight studies also helps in expert selection within a field. Here we demonstrate the importance of scientometrics in predicting the growth of scientific field. The concept of exponential growth applies to science in terms of number of units of scientific productivity, scientific papers. This was first highlighted by Derek D. Solar Prize in 1961 and 1963. Science, like any other phenomena of growth, seems subjective to a description in terms of logistic growth rather than pure exponential growth. This was the findings of Price. Why this type of growth happens, mechanism behind this growth were also postulated. The totality of scientific literature doubles every 15 years was shown by studies by Price and other scholars based on research publication trends. From an analysis of growth data, it appears on contrary that scientific disciplines and scientific subdisciplines may vary widely with respect to growth rate. So, it type of trend analysis provides important indications of scientific research activity of a country or a research group. It demonstrates a country's company's probability of success through patents. Patent based indicators can address to some extent the technology part of forecasting problem by analyzing which of the companies has the most valuable portfolio of patents, how concentrated is a company's R&D across different technologies, categories, etc. This similar analysis can be done for research units and country at large. Some of the indicators that are used in this type of analysis are number of patents granted by the patent office, say Indian Patent Office, number of cited reference per patent, a count of citation received by a company's patent, for example year-wise or otherwise, current impact index measures based on how often a company's patents are cited by other patents, the number of times a company's most recent 5 years of patent are cited in the current year related to the entire patent database, technology strength, the number of patent times the current impact index which indicates the technology strength of a company's newly issued patents. We look at some case studies on application of scientometrics in technology forecasting. This is a case study of GlaxoSmithKline. After the merger of SmithKline with Beckham in 1990, big question was guiding the focus of R&D resources. Scientometric mapping emerged as a very important tool in this regard. The two companies together had been working in 7 therapeutic areas. The big question was which of the areas had to be supported further and which of the areas where the research activity which was linking to the company's products were poor. Through scientometric analysis of publication trends and linkages derived from the publication analysis, gastrointestinal diseases were identified. Research was not significant by these two companies after merging. GlaxoSmithKline decided to close research activities in this area and to focus on research in the remaining 6 areas. Further, it identified research networks in the 6 therapeutic areas through scientometrics mapping, and from this intelligent mapping identified France as a location center for its central nervous system research activities. Thus, scientometric study gave the company an important intelligent perspective that enabled it to reshape its research portfolio for greater productivity and to define a number of promising technology opportunities. Slide 16. Case study of the importance of public funding for research for industrial competency. This study was done by Kai Research in 2004. What it showed? It shows that substantial citation to research papers in patents were from research papers, and majority of the research papers emerged from public funding of science. This highlighted the role of public funded institutions. It led to increase in research grant for public sciences in the USA. It also got noticed in other countries and had high spin-off effect. That is, many countries increased outlay for public science. This is a case study predicting the development trend of the walking technique through artificial methods. Objective of the study was to predict the development trend of the walking technique in Japan. Patent information of the biped robot walking technique in Japan from the patent database of the Japanese Patent Office were used to predict this trend. ESCAV Loglet Lab analysis, Pearl and Gompertz models were used. The study showed that the biped robot walking technique in Japan will continue to grow and reach saturation in the period 2079 to 2082. These type of findings help business managers and technical developers to manage their strengths of developing the techniques. It is feasible to predict the development trend of a technology using the approach presented in this study. So far, we have highlighted the importance of scientometric study and also the importance of scientometric study in forecasting, science policy, and in research evaluation. We have highlighted how scientometric studies help us to go for rational, objective decisions. Scientometric itself emerged from this demand from the decision making community to provide indications of how scientific research can be properly directed to achieve desired goals. However, we should be careful in undertaking scientometric study, because if we undertake studies without deeper introspection, it will not be acceptable to the scientific community and science policy decision makers. Problems of scientometric based research that requires attention can largely be categorized under methodological issues, issues of databases that include data mining and visualization tools, and lack of integration of scientometric research with other disciplines, and need for adopting reflexive self-critical approach. The need in fact is to make scientometric research not only a data counting exercise but also as a exercise in which we try to understand why a particular trend has emerged, what are the implications of this trend for decision making, for research, and how it can contribute towards better understanding of the qualitative methods wherein there is skepticism of using these type of indicators. Friends, in this module we have tried to understand and demonstrate how scientometrics plays an important role in science, technology and innovation policy. We have also shown that technology forecasting, one of the very important tools for policy mapping, in which scientometrics plays an important role. We have highlighted indicators constructed from scientometrics, how they can reveal the dynamics of a research field, how it can identify gaps in a country's research profile, and thus provide important inputs for policy makers. Also, we introduced through examples showing that how scientometrics has been used to by the industry farms to identify the resources mapping and then subsequent actions taken by them for strengthening their research and innovation ecosystem. So, in these demonstrations, we have highlighted that the role of scientometrics in policy making and decision making is much wider than many of us anticipate. Must look at scientometrics in a much holistic manner. It is not only about counting papers or patents, it is much more than that. From these different counting exercises, we are addressing some of the important challenges for our science policy making, innovation policy making, and it has implications for strengthening the research and innovation ecosystem of a country or a farm or a research unit. Thank you.